Okay, let us move ahead. Let us do some more simple questions on stack. So if let's say there is a stack and it contains 1, 2, 3 and 4. If I want to push 5, how much time will it take? It will just take order one time, right? So I'm saying, hey, I don't want to push 5. I want to push bottom 5. PB means push bottom. Push bottom means push this thing, but to the end of the stack. So when you perform push bottom operation, what would happen is that it would get converted to something like this. 4, 3, 2, 1, they will maintain their order, and just 5 will come over here. Right? This is the meaning of push bottom. Okay, so what did I say? Any operation that happens at the bottom end, which is the fixed end, that will be costly. Okay, so obviously you might be understanding this will be costly. Now I'll tell you one thing, you have to implement this push bottom function. So treat it as a function. This is a function that takes something which is to be pushed at the bottom, and it also takes the stack by reference which is to be pushed, in which the push bottom has to be performed. So these are the two things that this function takes. We need another stack for it, 2 stacks, insert at top, keep swapping. Yeah, so I wanted something like that to come up. So how many of you feel that is the right kind of way to work with stack? That is not. Why that is not the right kind of way? Because in a stack, even if let's say you implemented your own stack, should you ever tamper with any element which is not the top element? Should you ever do that? No, you should never do that. So the question clearly asks you to perform push bottom using standard operations of stack. I don't know why I have seen some people repeatedly seeing this but ignoring this, which is really bad. So it basically says that you just use the standard operations of stack, which are standard push, pop and everything. Top is empty, is full, to accomplish this. You should not do something which is anti-stack. So based on what he said that, hey, first put 5 over here and then swap 5 with this, and then swap that with this, that with this, that with this. So in this case, you are, touching the intermediate element of the stacks, which you are not allowed to do. So here you are just supposed to use the standard stack operations, push, pop, top, and those all, is empty, is full, right? And remember this forever. The moment I say that you have to implement a stack using standard operations, what I mean to say is something like this only, okay? That you should not tamper with the intermediate elements of the stack. So before this, let me ask you one thing. Have you guys ever used an inbuilt stack of your programming language, be it C++ or Java? Right, so I think you can very easily read about it. So in C++, it is very simple. Stack, the data type of the stack, which let's say is int. And then your operations are like s.top. It will give you the topmost integer. You have got s.pop. If you do s.pop, the topmost element gets removed and it returns nothing. You have got s.push, whatever you want to push. And you have got s.empty method also to check whether the stack is empty or not. And this data structure, this is implemented exactly how vector is implemented. This is a dynamic data structure. This doesn't have a predefined size. So when it sees that too many elements has come, it automatically expands its size. Okay. Yes, you can use it in your interviews. So see, interviewer generally makes you implement either complicated data structures, or he makes you implement that part of stack which he might feel tricky. Let's say somebody wants to check your corner case handling skill, so he'll ask you to implement push and pop to check whether you are using underflow overflow or not. If let's say he wants you to check that how efficient you are with space, then he will ask you to implement case stacks within the same array. But in any complicated question, if instead of writing the core code, you spend time on implementing the stack, then your time will get wasted. So you should learn how to use your own inbuilt stack. So it is very simple. This is all that it is, and you can use these things to get your task done. But please, when you go back today, learn about them. Okay, so what was the first solution over here? I want to push bottom 5 in this stack. How many of you are willing to use a separate stack? Okay, and I think that makes a lot of sense because let's say I use a temporary stack, call it temp. Now if one by one I pop from here and push here, pop from here, push here, pop from here, push here, pop from here, push here, then if this thing is 1, 2, 3, 4, what will this be? Will it be 4, 3, 2, 1? Yes. So this is a very important thing, and why it is happening again, why it is happening, that whatever is first out, that enters at the last point, and whatever is last out, that enters at the first point. That is the nature of the stack. So whenever you do this thing which we have done here from one stack to the other, whatever you get here will be reverse of it. So you will get 4, 3, 2, 1. Now don't you think so the moment again when I put this thing from here to here, so this is basically reverse of stack. And now when you put everything from here to here, you will get reverse of stack. And can I say reverse of stack is stack itself? Yes or no? I can say that, right? Cool. So now one thing is very, very sure, that even if I have got rid of this thing from here, I can make them come in the exact same order because of this thing. So now this is empty, and now I can easily push bottom. So see, whenever you have to push something which is not the top, then you have to free the elements as long as your top comes to that index where you have to push. There is no exception to this rule. If you have to push at I, your top should come to I, and your top will come to I only when it gets rid of the elements which are there. And please ensure to push them in other stack so that you can get them back. It is just like undo redo. So at this point of time, now you will push this 5 and now get this thing back over here. So this is what is the implementation of this. Any comments on the time complexity here? It will be order n, right? Because you removed n elements and then you inserted an element and then again you brought those n elements back. Okay, so here I use stack to do it. Can I do it using recursion? Let us try to understand the most important thing over here. This initially looked like 1, 2, 3, 4. So what was the element that got first out from here? 4. Okay, cool. And what was the element that got in here in the last? That is 4. That is also 4. Yes or no? Right? So you think of it like a pop that happened over here. And whatever got popped first, that got pushed in the last. Okay? And of course, I am excluding 5 to it. And whatever got popped in the last, that got pushed in the first iteration, in the first step itself. So what actually happens that you did something, and now before you perform this, you would want to do something else. And that something else can be your recursive call. What do you do in recursion? There is something that you want to do, but you do not want to do it right away. You want to do it in the end. So what do? You park it somewhere and you make a function call. And when that function call is over, then you execute that thing. So let's say you have 1, 2, 3 and 4. And you want to do a push bottom of 5. Okay? You want to do a push bottom of 5. So can I say that, hey, first thing that I'll do is, I'll pop the topmost element which is 4. I'll pop the topmost element which is 4, and then before I'm writing it 3 because before I push this 4 back, I will somehow want to call a magical function that performs a push bottom of this 5 in the remaining stack, which is 1, 2, 3. Because think of it in this way. See, think it line by line. Let's say first this happened. When this happened, then your stack looks like this. Now before doing this, you called a push bottom of 5 in this stack, and let's say this magically executed. So push bottom in 5, if that happened, then it would look like 5 here and then 1, 2, 3 here. And now after this, if you push this 4 over here, then you will exactly get what you actually wanted to get. So can I say that the step 2 that I have written should be a recursive call? Yes or no? The step 2 can be a recursive call where you are calling push bottom recursively on the modified stack. So I'm going to show you all, this is a very important interview question from recursion point of view. So I'm going to do a push bottom of, let's say, 4 in this stack. I have got 1, 2 and 3. Okay, so the first thing that I'll do is, what is the first thing that you do? What was my first step? Pop. Very good. So the moment you call pop, you'll get out this 3. Okay, and now you will call push bottom of 4 in the remaining stack, which is 1 and 2. And now when this is over, then you would want to perform push of something that you had already popped, which is push of 3, right? Now you are here. So before implementing this, you are here. So what will you do again? Again, the first thing you will do is whatever you did here, which was to call a pop. So when you call a pop, you get this 2 out. And now you will call push bottom of 4 in this stack containing 1. And then when this is over, then you would want to push back whatever you had popped. Now you are here. Again, you will first call pop. When you call pop, you get this 1 out. And now you will call push bottom of 4 in the empty stack. And after that, you will call this push off whatever you had popped. Should this be my termination condition? If you want to push something at the bottom of an empty stack, what is the way to do that? If you want to push something at the bottom of the empty stack, you should execute simple push, normal push, yes or no, right? So whenever you reach termination condition, you should simply do push off whatever you wanted to push, right? And now when this is executed, then which push will be executed? This push is waiting for this is waiting for this. So after this 4 comes here, and when this gets executed, now I have 4 and 1. And now when this gets executed, I have 4, 1, 2. And now when this gets executed, I have 4, 1, 2 and 3. So this is how things will actually work. So did you get this? How many of you can write code for this? Right? Yeah, it will be very easy, correct? So do you see here that this function, it has not got completely executed. I mean, it was waiting for this function, because once this gets executed, then only this will get executed. So this was waiting for this was waiting for this was waiting for this. Let's say the height of the stack was h. Then what would be the size of this recursion stack? It would be order of h. So internally, your recursive code also used a stack only, right? How is the code going to look like? So I'm just going to write a pseudo code. So void push bottom. Let's say x is this element that you want to push at the bottom. And this is your stack. It must be passed by reference. Okay, please do that. Please ensure this is passed by reference. Okay, and now what you can do is, how do you detect your termination condition? Can we detect the termination condition easily? I just have to check whether my stack is empty or not. So if you see that your stack is empty, then you will simply do stack.push x. Okay, you will do this thing and then you will return, right? Otherwise, what will you do? First thing to do is to pop. So you will call stack.pop, okay, and then you will recursively call this push bottom method for x and remaining stack. This stack is passed by reference, okay, and after this you will execute the final thing, which is stack.push whatever you have popped.